Hello everyone. In this question, it is asked that if alpha and beta are the real roots of the equation x square plus kx plus k square plus 2k minus 4 equal to 0, we are to find the smallest possible value of alpha square plus beta square. Okay, so let us start the solution. The given quadratic equation is x square plus kx plus k square plus twice k minus 4 equal to 0. Okay, and this has real roots alpha comma beta. Okay, so if we compare it with ax square plus bx plus c equal to 0, we get a is 1, b is k, and c is k square plus 2k minus 4. Okay, so this is in the bracket. So if there are real roots, this implies the discriminant of the given equation will be non-negative. Okay, so this implies your b square minus 4ac will be non-negative. So this implies k square minus 4 times 1 times k square plus 2k minus 4. This is the product is non-negative, right? Sorry, the b square minus 4ac term is non-negative. Okay, so if we further simplify it, we get k square minus 4k square minus 8k plus 16 is greater than equal to 0. Okay, so again this further simplifies to 16 minus 8k minus k square minus 4k square is minus 3k square. This is greater than equal to 0, right? Okay, so let us multiply both sides of this inequality with minus 1. Okay, so we get k square 3k square plus 8k minus 16 will become less than equal to 0. Okay, so this can be factorized into product is negative 48, right? So 12 minus 4 is plus 8, so this can be factorized. So this becomes k plus 4 times 3k minus 4, right? This is less than equal to 0. Okay, so these are the two possible values. So let us write it in the form of x minus alpha times x minus beta less than equal to 0, right? Let us make the coefficient of k in this equation 1 in both the factors. Okay, so the first term becomes k minus minus 4 times this becomes k times k minus 4 upon 3. Okay, less than equal to 0. We have taken the 3 out here. If the 3 comes out here, we can divide both sides by 3 as the RHS is 0, so 0 by 3 will be 0, so no issue here. Now in this equation, if x minus alpha into x minus beta is less than equal to 0, and if we assume here if alpha is less than beta, then from here we can conclude that alpha less than x less than beta. Okay, so in this our case, negative 4 lies to the left of 4 upon 3, right? That is here minus 4 is less than equal to k less than equal to 4 upon 3. 4 upon 3 is 1.333. Okay, so this implies k belongs to the interval, closed interval, since it is less than equal to, it is minus 4 comma 4 upon 3. Okay, so this is the range for k. Okay, so far so good. Now let us find out the sum of roots and the product of roots, and we'll try to compute the value of alpha square plus beta square. Okay, so we have alpha plus beta will be on minus b upon a, which is equal to b is k and a is 1, right? So it's minus k, and alpha beta will be c upon a, which is this constant term k square plus 2k minus 4. Okay, k square plus 2k minus 4. Okay, so let us find out the value of alpha square plus beta square now. this will be alpha plus beta whole square minus twice alpha beta, which gives minus k whole square times minus 2 times k square plus twice k minus 4. Okay, so this becomes k square minus 2k square minus 4k plus 8. Okay, so this becomes equal to 8 minus 4k minus k square. Okay, so this becomes a function in k, the value of alpha square plus beta square. This becomes a function in terms of k. Okay, so k belongs to this interval minus 4 to 4 upon 3 both included. Okay, now this the nature of this curve, this alpha square plus beta square, this curve, this will have a downwards open parabola of a quadratic curve, right? Since the coefficient of quadratic, the square term k square, the coefficient is less than 0, right? It is minus 1 here. So this curve will be a parabola where the downward side, the downside is open. Okay, so for this curve, for such a curve, the least possible value has to be either this extremity point or this extremity point. Okay, so in our case the value of k ranges from minus 4 to 4 upon 3, right? So the least value of this curve will be either at k equal to minus 4 or k equal to 4 upon 3. This cannot be any value in the interval, in intermediate value. Intermediate value will never be the least value for such curves, right? So let us find the value of alpha square plus beta square at k equal to minus 4 first, and then at 4 by 3, and we'll compare the values and we'll see which one is smaller, right? So at k equal to minus 4, alpha square plus beta square at k equal to minus 4 gives us 8 minus 4 times minus 4 minus minus 4 whole square, which gives us 8 plus 16, and this becomes minus 16, so this gives us 8, right? Okay, and now let us find out the value of alpha square plus beta square when the value of k is 4 upon 3. Okay, so this gives us, this is 4. Okay, 8 minus 4 times 4 upon 3 minus 4 upon 3 square. We've just plugged the value of k in this alpha square plus beta square expression. Okay, so this becomes 8 minus 16 upon 3 minus 16 upon 9. Okay, so if we take the LCM, this 8 times 9 will become 72 minus 3 times 3, 16 times 3 becomes 48, and this is 16. So this becomes 72 minus 48. 48 and 16 becomes 64. 72 minus 64. This becomes 8 upon 9. So clearly 8 by 9 is less than 8. So the least possible value has to be this one, 8 by 9. Okay. So therefore smallest possible value of alpha square of alpha square plus beta square is 8 upon 9, which happens for k equal to 4 upon 3. Okay, so this is the final answer. Okay, another point that I wanted to show, this was the the smallest value, right? The peak value of this expression, this happens at the vertex. Okay, so if we are to find the maximum value, okay, the sum is done, this is extra. Okay, this is extra part, extra. For maximum value of alpha square plus beta square, we need to find value of k at its vertex. Okay, the maximum value of happens at vertex of the curve. Okay, and the curve in our case was this 8 minus 4k minus k square. Okay, this 8 minus 4k minus k square. Okay, so if we are to compare this curve again with the standard form, we get a will be equal to -1, b will be -4. This is a quadratic in terms of k, right? So coefficient of k square is -1, coefficient of k is -4, and c is +8. Okay, and the x coordinate of the vertex of the curve will be minus b upon twice a. Okay, so this gives us -4, minus of -4 upon 2 times -1. Okay, so this gives us +4 upon -2, which gives us -2. Okay, so this maximum value will happen at this -2, and -2 lies between -4 and 4 by 3, right? So again, let us finally compute the value of alpha square plus beta square, the maximum value, which happens at k equal to -2, which is, what is the expression? 8 minus 4k minus k square. 8 times minus 4k is -4 times -2 minus k square. Okay, so this gives us 8 plus -4 times -2 is 8 again, minus 4. So this is 16 minus 4, it is 12, right? So this is the maximum value. Okay, so our question was to find the smallest possible value. So we started with the condition of the real roots. We solved the discriminant, then found the interval range for k. Then after computing the value of sum and product of the roots alpha beta, we computed the value of alpha square plus beta square, which was a quadratic expression in terms of k, which was downwards open. Okay, so for downwards open, the smallest value happens at the endpoints, and the peak value happens at the maximum value happens at the vertex. So we computed the values of alpha square plus beta square at the endpoints -4 and 4 upon 3, and we found out that the value was smaller at 4 upon 3. Okay, and the smallest value came out to be 8 upon 9. Okay, and then we found out the maximum value also, but this was extra, like this is not required, just like I wanted to find the value, maximum possible value also. So this is it. The final answer is 8 upon 9. Okay, so thank you.